Good morning, students. Once again, welcome to our laboratory number 4, entitled Operational Amplifiers. Okay, so the main objective of this experiment is to measure the gain and closed-loop bandwidth of inverting and non-inverting amplifiers. Okay, now equipments needed. We need a function generator. So function generator is located in our KNH trainer. Okay, we have the frequency and the amplitude. Okay, in other KNH trainer, the amplitude are on this below, no, and the frequency is located at the upper part. Okay, but all in all, this side is the function generator. Okay, and we need two power supplies, no, the positive 15 volts, it's here, no, positive 15 volts and negative 15 volts. Okay, and also we need resistors. Okay, resistors here, so we need around 4.7 kilo ohm and 100 kilo ohm and another 4.7 kilo ohm to our load. Okay, so let us locate 4.7 kilo ohm, it's here, 4.7 kilo ohm, and 100 kilo ohm located somewhere here, 100 kilo ohm. Okay, all right, and lastly but not the least, we need an IC, no, an integrated circuit named op-amp 741, no, here, no, 741. Okay, all right, so we need a 741 operational amplifier IC. Okay, all right, so in this experiment we have two types of op-amp amplifiers. We have the inverting amplifiers and the non-inverting amplifiers. Okay, in our practical, during the actual lab, we will do only the inverting amplifier. Okay, we'll do it through breadboard, no? I'm gonna show it to you. Okay, and the second one, the non-inverting, you do it with the using the multi-sim software. Okay, all right, so let us go to inverting amplifier. All right, so open your laboratory manual, laboratory number 4, name operational amplifier. All right, and go to the page number 4. Okay, page number 4, 3 and 4, page 3 and 4. Okay, so in page 3 you can see the inverting amplifier circuit, no, and you'll see also a circuit using the multi-sim. Okay, so this circuit is named inverting amplifier. Right, so we will implement this inverting amplifier using the KNH trainer. All right, so let us begin. So first, get your 741 IC and put it here, no, somewhere in the middle. Okay, like that. Okay, I'll move it closer so that you can see a little bit. Okay, put it here, no, so it should be in between, in this line. Okay, in between, and you can see a small circle notch, no, small circle notch at the top, no, here, no, there's a small circle here, the notch. Okay, so it will be, positioned to the top. Okay, or above. Okay, all right, so put the 741 similar to this position that I have done. Okay, once you're done, then connect the get the resistor 4.7 kilo ohm resistor. Okay, so 4.7 kilo ohm, so where is it? Here, 4.7 kilo ohm. Okay, so get the 4.7 kilo ohm and then connect it to pin number 2 of the operational amplifier. So where's pin number 2? So you count from here, no, from the left. Okay, from the left, start from the above. So count 1, 2, 3, 4, 5, 6, 7, 8, like that, no, in U shape, no. So number 2 will be in this side, no? So connect number 2, connect a 4.7 kilo ohm. All right, as indicated in the circuit. Okay. All right, I'll make it focus so that you can see a little bit like that, no? So it should be in number 2. Right? Okay, let us continue. All right, so you put the 4.7 kilo ohm to the 741 integrated circuit for IC. Okay, the next is to get 100 kilo ohm. Okay, here, no? So 100 kilo ohm. So get 100 kilo ohm and connect it also into number 2 and number 6. Okay, so from here, number 2, so 4, 5, 6 here. Okay, like that, no? And then get a 1 kilo ohm resistor. Okay, 1 kilo ohm resistor. So 1 kilo ohm resistor, put it in number 6 and ground. Okay, number 6, okay, to the ground, no? Like that, no? Okay, so I'm gonna get some color block here and put it here to the ground. Okay, then next is connect number 3 also to the ground. Okay, so number 3 also to the ground. Okay, so number 3 here is number 3 here to the ground, like that. Okay, and next is to connect so number 2 already connected. Okay, okay, next is to connect the number of, or the number 4, okay, number 4 to the negative. All right, number 4 to negative 15 volts. Okay, so from here, number 4, connect it to the negative 15 volts here. Okay, like that, no? And number 7, connect it to the positive, no? So 6, this is 5, 6, 7, no? Here, connect it to the, okay, I need a little bit longer wire. So this is 5, this is 5, 6, 7, okay? So connect it here. Okay, connect it to plus 15. All right. Okay, like that, no? And okay, and last is the signal, no? Signal coming from here, no? From the output here. All right. So let us connect. So I think I need a little bit longer wire. Okay. So from here, no, from 4.7, connect it to the output here. All right. And lastly, connect a wire from the ground, no, to the ground here. Okay. Just wait a minute. I'm gonna put some power. Okay. All right. So switch on the power. Okay. Switch on also the power of the oscilloscope. Okay. On the power. So you'll be needing this one, no? You need a banana or BNC to, sorry, BNC to the alligator, no, wire, no, for oscilloscope. Okay, a little bit that. Let's, okay. All right. Okay. Now you need to input a 1 volt, no, 1 volt peak to peak. Okay, 1 volt peak to peak and 1 kilohertz. Okay, 1 volt peak to peak and 1 kilohertz. Okay, so connect this here, no, to your input. Okay, connect here to the input. Oh, sorry, like that, no. Just wait for a minute. Okay, then connect this one to the ground. No, sorry for that. You need to connect it properly, like that, to the ground. No, as you can see, I have a, no, I have a waveform there, no, waveform. So I have 1.033, no. All right. So adjust this, no, by adjusting the frequency in the function generator, no. Adjust it, make it 1 kilohertz. Okay. So initially we will do 1 kilohertz. Okay, adjust it until you get 1 kilohertz. Approximately, okay? Okay, like that. And 1 volt peak to peak, no? As you can see from here, it is 3 volts, no? So I'm gonna reduce it. I'm gonna make it 1 volt peak to peak. So I'm gonna increase also the time, I mean the volts per division. Okay, like that. I'm gonna also increase the time. All right, so I have 1 volt peak to peak. Okay, the yellow color is 1 volt peak to peak. That is my channel 1, that is my input. All right, okay, now what you need to do, get another alligator to BNC. Okay, then connect it to channel 2. Okay, connect it to channel 2 and get a wire, get a wire, connect here to this alligator. Okay. All right, like that, and connect the block to the ground. Okay, and the red, connect it to the output, no? The output of our circuit will be in number 6. Okay, number 6. Okay, and in the power supply here, no? This, no? Here, the power supply, increase this to the max, increase also this to the max. All right, so as you can see, no, look at the waveform, no, the purple. Okay, the channel 2, that is the waveform coming out from number 6. Okay, let's reduce the amplitude. All right, and move it a little up. So look at here, no? So our input, no? Our input amplitude is 1 volt. Okay, it's 1 volt. And the output now, it's 21.6. Look at there, no? It's 21.6. If you try to look at the peak to peak, the value is 21.6 volts. All right. Okay. And look at the waveform. No, what have you observed in the waveform? The waveform is inverted. No, look at here. No, this is our input like this. However, the output will be like this. No, it is inverted. No, it's like a mirror. All right. So that is the inverting amplifier. Okay. So now what you need to do, you have the table. No, you have a table at page number 6 of your manual. Okay, you have the table. Not okay, not page number 7. Sorry, it's page number 7. It said inverting amplifier. Okay, inverting amplifier. Okay, so keep the amplitude 1 volt peak to peak, and adjust the frequency. Okay, adjust the frequency. Start with 20 hertz. Okay. Okay, actually you already done this, no, in one of our labs, so no need for me to show to you how to do it. Okay, but first you need to do 20 hertz. Okay, 20 hertz. All right, so look for 20 hertz. Okay, adjust the time if you cannot see. Okay, this is 26 hertz. Okay, just a little bit, make it 20 hertz. Okay, so I have 20.54 hertz. All right, get the input voltage, the B peak to peak, the yellow, and get the output B peak to peak. That is your purple, color purple, no, of your oscilloscope. Okay, once done, then change to 60 hertz. Okay, change to 60 hertz. Okay, not exactly 60. You can do 65, 63. So it's okay. Okay, make it 60 hertz. All right, once done, get the input and get the output. Okay, and continue to 100 hertz. Do it also in 100 hertz. Change the frequency here, no, to 100 hertz. Okay, I'm changing the frequency, in my function generator. Change it to 100 hertz. Okay, then get the input and get the output. All right, so once done, then go to 300. Okay, go to 300. Okay, so the input, no, in 20 hertz is still 1.02, and my output is 21, no, 21.2, no. So it's all the same, until, no. So I will do now the 200 hertz. Okay, I'm gonna increase the frequency to make it 200 hertz. Okay, 211 or 210, it's okay, no, or 207. So I have in my case I have 210 hertz. So still I have B peak to peak 1.02, and my output is 21.2. Okay, so copy, just get the amplitude, okay, of both waveforms. Okay, next go to 300. So increase the range, no, put it into 2K, or just increase the range to 2K or 1K. Then adjust the frequency and do the 300 hertz. Okay, I have 300. I have 308 or 300. I think I have 300 hertz. Okay, so adjust the time so that you can see it perfectly. And then you have the B peak to peak, same 1.02. And the output is 21.2 still. All right, So next, 500 Hertz. So change this to 500 Hertz. Okay, so I have 505.8 Hertz. And still my B peak-to-peak input is 1.02 and my output is 21.2. Okay, 21.2. All right. So next, I'm gonna increase it to 600. Okay, I'm changing it to 600. So I have here 610 Hertz. Okay, it's okay. All right. So my B peak to peak, B peak to peak is still 102. Okay, still 102, and my output is 21 point, no, around 21.8 or 21.2, no? Still the same. All right, so I'm gonna increase my frequency again to 800 Hertz. So just keep increasing the frequency and get the input and output. Okay, I have 800 Hertz. All right, my B peak to peak is 1 volt, and okay, my B peak to peak still, no, 21, no, 21.2 volts. Okay. All right. So make sure your input is always 1.02, no. So if it is decreasing, make sure to put it in 1.02 all the time. Okay. Or 1 volt. Okay. All right. And now increase it to 1 kilohertz. Okay. Still, no, 1.02 and 21.2, no. My All right. So do also in 4 kilohertz. Okay. So I'm gonna increase my range to 20K. So because I want to do 4 kilohertz. Okay. So 4 kilohertz. Okay, that's 4 kilohertz. Still, I have 21.2, no, and 1.02. All right, and get also the 8 kilohertz. Okay, now my B peak to peak decrease a little bit, so it become 20.4. Okay, so I'm gonna increase it to, next is 10 kilohertz. Okay, 10 kilohertz. Now it's 19.2, but still the same. The input is 1.02, but my output is 19.2. Okay. Next is 20 kilohertz. So I'm gonna do 20 kilohertz. Okay, make sure your B peak to peak, no, input is still, no, 1.00 or 1.02. Now my B peak to peak is become 11.2. All right. So in 10 and 20 kilohertz, my output is 11.2 volts. Okay, but still my input is 1.02. Okay, adjust the range, put it to 200K. All right. Okay, go to 40 kilohertz. Okay. 40 kilohertz. All right, make sure your B peak to peak, make it 1.02. Adjust it, 1.02. All right, so look at your output now, no? So your input is still 1.02, but your output is 5.6. 0.02, now 5.6 volts, okay? And lastly, do the 60 kilohertz. Then we're done, okay? Until 60 only.